The second half of section 3.6 is the half angle formulas. And ironically, we're going to start with the double angle formulas. In particular, double angle formulas that we get from the cosines, so these right here, and in particular these last two. Now notice that there's a nice relationship between this angle and this one. This one is half of this one. So how are we going to use that? Well, let's start out with our cosine double angle formula, at least one version of it. And you don't have to memorize this, I'm just showing you how it's derived. But if we take the 1 and move it to the other side, then we get this. Then we can divide both sides by 2, so I get this. To get rid of the square root, I'll take the square root on both sides. And notice I got a plus or minus the square root here. So, okay. And the relationship here is that this angle is twice this one. And a different way I can write it is that the cosine of theta over 2 is plus or minus the square root of 1 plus cosine of theta over 2. So, okay. This gives you a way to calculate the cosine of half of an angle. So if you know the cosine of an angle, you can find the cosine of half of that angle. Now, what exactly do I mean by that? Well, let's do a couple examples. By the way, the derivation for the sine half angle formula is pretty much the same. It just starts out with a different cosine double angle identity up here, but you end up at more or less the same place. The only difference between these two formulas, here and here, for sine and cosine, is that one of them has a plus and one of them has a minus. And it's going to be your job to kind of remember these, keep them straight. My suggestion is that on the exam, when you first get your exam, you write down this formula or this one or both right at the top of your exam before I even start talking about the instructions or whatever. It's called a memory dump. And then you've got that, so you don't have to worry about remembering the formula later on the test when I tell you there's only 10 minutes left and you panic. So take advantage of that. It's a good little test taking strategy. Now, where are we going to use this formula? What's it used for? Well, here's an example right here. Let's take a look at the sine of 22.5 degrees. So I'll kind of continue with where I was with my last section, kind of the first half of this video. And that was example E, so this would be example F. Example F. I want to find the sine of 22.5 degrees. Now, I'm not talking about a decimal value. Anyone can get that. Just punch it in your calculator. If I want an exact value, I might notice something interesting about 22.5. It's half of a more familiar angle. Does anyone know what it's half of?
45.
Yep, half of 45. Perfect. And so according to our formula then, this is going to be plus or minus the square root of 1. I was going to think it's going to be minus cosine of 45. That's a 5 in there. All right. Well, we know the cosine of 45, or at least we can figure that out. Cosine of 45, is that your y-coordinate or the x-coordinate at 45 degrees?
X-coordinate. Doesn't matter.
In this case, it doesn't matter, but the sine is your y-coordinate. In this case, like I said, it doesn't matter. So this is going to be plus or minus the square root of 1 minus square root of 2 over 2 divided by 2. Now this is a little bit messy, and so you might have to clean this up a little bit. Let's work on that. And the way you work on that, the way you work with complex fractions like this, is you multiply by the lowest common denominator of these secondary fractions. So what I'm going to do is I'm going to multiply in the numerator and denominator by 2. So I'm going to multiply 2 over 2. What's 2 divided by 2? Just this part. 2 divided by 2 is 1. So multiplying by 1 doesn't change the value of it, but if I distribute that 2 into the numerator, I will get some nice cleaning up. I'll get 2 minus what? Square root of 2.
Square root of 2.
Yeah, thank you, gentlemen, because this 2 cancels that one. Over 4. And now, let me break it up as the square root of 2 minus the square root of 2. If I just take the square root of 4, I can get that 2 out from underneath the radical. And the last thing to do with is the plus or minus. Do I want a positive root or do I want a negative root? Well, you got to think about where this angle is. That angle is in the first quadrant. Is sine positive or negative in the first quadrant? It's positive. All right, so that's your answer. Now, it doesn't hurt to check your answer, but before I mess with that, are we okay with how I got that answer? It's just plugging in that formula. That's all we did here.
How did you know to multiply or distribute a 2 to the numerator and denominator?
That's just some algebra. It's an algebra trick. Essentially what you're doing here is you're multiplying by 1. But whatever this denominator is, if you multiply by the lowest common denominator of these secondary fractions, you can cancel out that little denominator. It's going to make your expression a lot simpler. So that's what we did here, is I multiplied by the LCD of these types of fractions. In this case, there's only one of them. So it's 2 over 2. That help, or you're still a little unclear there?
I'm good now, thank you.
Okay, we'll do another one like that. Let's check our answer on our graphing calculator. Now, the one way to do it is to check it in degrees. So I'll start out with that. Sine of 22.5. Okay. Let's compare that to the square root. Where's my square root? Square root of 2 minus the square root of 2 again. And notice that that second square root is underneath the first one. I'll have to press the right arrow twice to get out from underneath those, and then divide the whole thing by 2. Bingo. Exactly the right thing. It might be better for you in terms of checking it if you hit the alpha key and then the y equals key. That allows you to draw a regular fraction like we do, like I just did here just a minute ago, and then do it this way, square root of 2 minus square root of 2 again, and then down to the denominator divided by 2. Beautiful. Notice if you hit the answer to fraction key, it's not going to change anything. That's because you can't write this as the ratio of 2 integers. It's not a rational number. Let's keep going. Let's try another one. Let's make these a little bit more interesting. We'll start with problem number 26. So I'll call this one example G. Sine of 195 degrees. And the instructions tell you to use the half angle formula to find the exact value for each expression. So, okay. So I got to figure out 195 is half of what angle? Well, you can just take your calculator and multiply 195 times 2. Pretty sure you're going to get 390. So let's fill in the 390 into our sine half angle formula. It's going to be plus or minus 1 minus cosine of 390 over 2. Okay. Cosine of 390. Well, let's think. That's more than once around the unit circle, right? So I can kind of make this a little bit smaller of an angle if I work with a coterminal angle. 390 is all the way around the circle and then a little bit more. How much more?
30.
30 degrees. So this is essentially cosine of 30. And maybe you're a little bit more comfortable with 30. What's the cosine of 30?
Square root 3 over 2.
Thank you. A couple people getting that one. There's still that plus or minus out here that we've got to deal with yet. Okay. Last but not least, let's play the game that we did just a minute ago. That square root, by the way, goes all the way down over the 2. Don't leave that out. In the game we played just a minute ago, I took this and I multiplied to get rid of the fraction here. I multiplied by 2 over 2. So if I distribute here, why don't you see if you can't beat me in distributing? What's that going to be in the numerator? I'll help you out in the denominator, that's a 4. What's left in the numerator?
2 minus square root 3.
2 minus square root of 3. Finally, I'm going to break this up into the square root of the numerator and the square root of the denominator. Square root of the denominator, I'm not going to write that. Square root of 4 is just 2, so let's just write it as a 2 in the denominator. Square root of 2 minus the square root of 3 over 2. But now we got to decide, is it going to be positive or negative? And here's the thing. Think about 195 degrees. What quadrant's 195 in?
First.
195?
Oh, 195.
First, second, third, or fourth, yeah. All students take calculus. Is sine positive or negative in the third quadrant?
Negative.
Negative, yeah. So if you do all this work and you forget the negative sign, my math lab's gonna mark you wrong, which just really hurts. But the good news is that, first of all, you can check your answer before you hand it in. And secondly, on a test, if you forget that, that's only like 1 or 2 points. So it's not gonna kill you if you forget on the test. I'm much more forgiving than my math lab is. Do we wanna check it on our calculators, or did you see it once, you're good with that? All right, let's move on then. So we'll do a couple more like that. Let's see. Let me let's try cosine of negative 3/8 over pi. So problem number 30 here, although I'm going to call it example G. Example G. Cosine of negative 3 pi over 8. Okay, so if I'm going to use the half angle formula, then I need to write this as something divided by 2. So if this has been divided by 2, to figure out what it was divided by, I need to multiply that by 2 times 2. And for convenience, I'll think of it as 2 over 1. Now, if you're looking at this and going, oh, I hate fractions, let's make our life a little easier. 2 cancels into 2 once, and into 8 4 times. And that makes the multiplication pretty easy. It's just negative 3 pi over 4. So our first step, figure out what theta is by multiplying by 2. All right, so that gives us the 3 pi over 4. Negative 3 pi over 4. Now I'm going to use my cosine half angle formula. So we'll see about that. So call cosine of theta over 2 is plus or minus the square root of 1 plus cosine of theta all over 2. And this is my theta. That's what we did here, is we figured out, well, this is half of what angle? And that's why we multiply by 2. So cosine of negative 3 pi over 4 divided by 2 is plus or minus the square root of 1 plus cosine of negative 3 pi over 4 divided by 2. Now I'm going to step back here for a second and use something I don't use too much, but I probably wouldn't hurt me to use a little bit more often, and that is our even odd properties. So going back way to the beginning here, cosine is an even function. So cosine of negative theta is the same thing as cosine of theta. Secant of negative theta is also secant of theta. These are the only two even functions. Doesn't matter if you take the cosine of negative pi over 3 or the cosine of pi over 3. You're going to get the same thing. Same thing with the secant. With the rest of our trig functions, these are odd functions. So the negative comes out. That's sine of negative sine of theta, negative cosecant of theta, negative tangent of theta, and negative cotangent of theta. So basically I'm just going to use this idea right here, just because it's convenient and just because we should practice it a little bit. So it's going to be plus or minus the square root of 1 plus cosine of 3 pi over 4. Okay. What's a cosine of 3 pi over 4?
Root 2 over 2.
Pretty close. Negative root 2 over 2.
Negative.
Yeah.
Sorry.
That's okay. But I appreciate your help. Thank you. So it's going to be 1 minus, or 1 plus, negative root 2 over 2 over 2. And by now, I hope you're getting used to our little trick here in terms of simplifying this. So we're going to multiply the numerator and denominator by 2 over 2. When I distribute that, I end up with plus or minus 2 minus the square root of 2 over 4, or square root of 2 minus square root of 2, or minus square root of 2 over 2. And last but not least, I got to decide if that's going to be positive or negative. And I guess it depends on the magnitude of 3 pi over 8, what quadrant that is in. So 3 pi over 8 is in the first quadrant. That would be, let's see what, 67.5 degree angle. Is that right? Yeah, 67.5 degree angle. So because, actually, 3 pi over 8 is in the fourth quadrant. All right, so it's a negative 67.5 degrees. Is cosine positive or negative in the fourth quadrant?
Positive.
Choose the positive root. Yeah, so choose the positive root. All students take calculus. Cosine and its reciprocal, the secant, are positive in this quadrant. You don't have to put a plus there, that's fine. There's your final answer. Beautiful. Okay. Maybe one more. Maybe two more. Any comments or questions on this one before I move on to kind of a last example here? All right. Let's take a look at problem number 14. This one's a little bit more challenging, but we've built up to it, so hopefully you'll be okay. So sine of theta is negative square root of 3 over 3, and theta is in the fourth quadrant. So they don't actually give you as much as they did in some of the other ones. That's okay. Let's see, sine of theta. This is going to be example G. I think so. Example G. No, example H. Example H. So sine of theta is negative square root of 3 over 3, and theta is in the fourth quadrant. So that's what they're telling you with this information right here. Now, let me give you a heads up with regards to math problems. In my experience, and I've been teaching this stuff for quite a while, mathematicians don't like to waste words when they give you a problem. If they give you some information, you're going to need it. So make sure you use this information. Now, one of the questions you could be asked would be, find sine of theta over 2. And we kind of have a lot of what we need, but not everything. So let's write our formula first. That's going to be plus or minus the square root of 1 minus cosine of theta over 2. Okay, not so bad, except for my theta, which looks awful. There we go, there's theta. Well, I need to figure out what cosine of theta is. And at least it tells me that I'm in the fourth quadrant, so I can draw this. Let's practice drawing a triangle here. So I'll just draw something in the fourth quadrant. I'm not going to take too much care to try and draw it to scale because most of us aren't terribly familiar with the square root of 3. Let's see. Draw yourself a hypotenuse. And then here. So that's going to be opposite over hypotenuse. So negative square root of 3 and 3. Opposite hypotenuse. So that leaves me to figure out what b is. A squared plus b squared equals c squared. So a squared plus negative square root of 3 squared equals 3 squared. A squared plus 3 equals 9. A squared equals 6. A equals plus or minus the square root of 6. Which one should I choose, the positive root or the negative root?
Positive?
Yeah, the positive. Because you're in the fourth quadrant, so that the x direction is going to be here. Now you can see my scale is off. This looks longer than this, but it doesn't matter. As long as the sides have the right number. You don't have to draw the triangles in proportion. But that's great, because now I can figure out what the cosine of theta is. So it's going to be sine of theta over 2 equals plus or minus square root of 1 minus cosine of theta over 2. What's the cosine of theta? What's the cosine of theta? Cosine is,
You're right, 6 over 3.
good, it's going to be adjacent over hypotenuse, square root of 6 over 3. And that's the key step here, is getting that number. Let me pause. Are we okay with finding the triangle and finding this side? Finding that ratio here. I mean, if you get here, you've got most of the points. There's still some to go, but you've got most of the points. So make sure you're okay getting here. Are we good on that? All right, I'm not hearing any dissent. So let's keep going. I'm going to try and clean that up. Plus or minus square root of 1 minus square root of 6 over 3 over 2. What should I multiply by this time to clean this up?
3.
Yeah, so 3 in the numerator and 3 in the denominator. Thank you. So that's going to give me plus or minus 3 minus the square root of 6 over 6. And I'm going to leave it like that. All right, I could rationalize this, but it's really starting to look pretty ugly as it is. So I'm going to leave it like this. But there's one last thing I need to take care of, and that's the plus or minus. Before I do, are you looking good there? There's a few cameras I'd like to see turned on, about 5 of them. So thank you. Now the question is plus or minus. Well, I guess to determine plus or minus, you need to know what quadrant this angle is in, right? Where is theta over 2? So let's take a look back at what they gave us at the very beginning. So recall that 3 pi over 2 was less than theta, was less than 2 pi. I want this to be theta over 2. So here's my trick for you. To get that to be theta over 2, I'm going to multiply everything by 1/2. 1/2 times this, 1/2 times this, 1/2 times this. What's that going to give me? What's 1/2 times 3 pi over 2?
3/4.
3 pi over 4. 1/2 times that, that's theta over 2. What's 1/2 times this?
Pi.
Just pi. So theta over 2 is between 3/4 pi and pi. So theta over 2 is in what quadrant? What quadrant is theta over 2 in?
The second.
Yeah, the second quadrant. Nice. So James helped you out here. Not sure if you heard it, but he's right on top of that with second quadrant. Someone else tell me, is sine going to be positive or negative in the second quadrant?
Positive.
Positive, yeah. So overall, you should end up with something like that. Nice, nice. Tough one. Look out for that. Like I said, they're not going to give you information that you don't need in a math problem. Keep that in mind as you work through these things. Any last comments or thoughts on example H? All right. Let's call it a day for section 3.6.